This is section 1.7 and this is video 2. Today we are focusing on the composite functions part of this section. So we're really going to be focusing on composite functions, and this is 2 of our targets for this chapter. Going ahead and starting, the first thing is looking at the notation for composite functions. Now you've probably seen this f of g of x notation in the past. Remember, this is where we take g of x and we put it into the f function. The other way you'll see it written is this notation with the little o in between them. I like to say fog f of g of x. These two mean the same exact thing, and so it's important just to know the difference between the notations. We'll go ahead and work out some examples. So the first thing we're going to find for these 2 functions given is f of g of x. Now remember, we start on the inside, and this means that we're going to take the g of x function, because g of x is in the inside, and we're going to put it into the f function. So doing that, finding, and I'll write it this way as well, f of g of x, same notation, means the same thing. We're going to take 3 times x squared minus 2x plus 6, and then we still have that minus 4 out there. And this is a case where parentheses become really important for us. Doing a little bit of simplifying, we can distribute the 3. So we'll get 3x squared minus 6x plus 18 minus 4. And a little more simplifying gives us an answer of 3x squared minus 6x plus 14. And this is what f of g of x would equal. We can do the same thing, only now we can do g of f of x. So using the same 2 functions, we're going to go the other way. We're going to start with g of x. We're going to start with f of x here, because f of x is in the inside, and we're going to put it into all the x's in the g function. And so let's go ahead and try that now. So for g of f of x, we're going to get 3x minus 4, and we're going to have to square that, minus 2 times 3x minus 4 plus 6. And once again, parentheses are really important in all these cases. To square 3x minus 4, you have a couple options. You can use a rectangle and multiply 3x minus 4 times 3x minus 4. You could also use the shortcut that we learned. If you use the shortcut and you square the first term, we'll get 9x squared. Multiply the 2 of them with the 2 in the middle with a 2, and you're going to get 24x, because you'll get 12 times 2, and square the negative 4 and you get plus 16. You can also multiply with the rectangle to get the same answers, as you can see here. So either way you go through it, you should come up with 9x squared minus 24x plus 16. We'll distribute the 2, so we get minus 6x plus 8 and a plus 6 out at the end. Looking for terms to combine, it looks like our x squareds don't combine with anything, but I have negative 30x's, and I have positive 16, positive 8, and positive 6, and it looks like that totals up to be 30. And there's our final answer for g of f of x. Alright, moving on, we are now going to talk about the domains of these. Before we talk about the domain, let's just start by pausing our video, and why don't you find f of g of x. Alright, now this one is a little bit more tricky because we have a few things going on. The first is when you take that g of x and put it into the f function, you end up with a fraction. So what I did is I took this one whole and I changed it to x over x. That way I could subtract with common denominators. The other thing to remember is that dividing by a fraction is the same thing as multiplying by its reciprocal. So I was going to flip over that 3x minus x. And finally multiply straight across the top and straight across the bottom. Now, thinking about what we know from domain, right away, I hope looking at this, you see that x can't be 3. The problem is if that's all you answer, you're going to be missing a spot where there's also a problem. So let's talk about the steps now in order to find the domain so that we make sure we get all the pieces. Remember, domain is our possible x values, so that's what we're looking for, is all the possible x values that will work. And we have a couple things in order that we have to look at to exclude. The first thing is we need to look at the inside function, in this case the g function. And we want to exclude any x's that won't work there. So looking at this g function, I can see that right away x cannot be 0. If x is 0, we're going to have a 0 in the denominator. So that's the first thing we have to exclude, is 0. Now notice, had we just used our answer for f of g of x, we would have missed that 0 right now. So that's the first thing. Look at your inside function, take out any x's that won't work. In this case, x can't be 0. Now here's the next part. The next part says is we need to take out any x that makes g of x not work in f. So basically, here's what that means. That means we need to look at the f of x function, the outside function, and we need to say what won't work there. The thing that won't work there is x equals 1. X equals 1 will give us a 0 in the denominator. Now remember, 3 over x is what's going into that x. So really what we need to look for is when does 3 over x equal 1. Whenever that happens, that's when we will have a problem. So when does 3 over x equal 1? Let's see. If I multiply both sides by x, that's where I get that x can't be 3. Because 3 over x can't be 1. So now these are the two things we need to exclude from our domain. The way we can write this in our interval notation would be that we're going to start and we're going to go from negative infinity all the way to 0. But we're going to close our parentheses there and hop over 0. We're going to continue on to 3, and then we're going to hop over 3, and then we'll finish off going to infinity. So let's go ahead and look at the next example. Given two functions, the same thing, we're going to find f of g of x and then the domain. Starting with f of g of x, we'll go ahead and take that g of x function and put it into our f of x. When we do that, we should end up with 2 over the square root of x minus 3. Now we'll go ahead and talk about finding the domain. The first thing we want to do is go ahead and look at the g of x, our inside function. And we want to talk about the domain of g of x. Now, g of x is the square root of x, so we know all of our x's have to be greater than or equal to 0. That means if we want to think about what we're going to exclude, we're going to exclude everything that is less than 0, meaning all of our negative numbers. The second piece is to look at f of x. Now looking at f of x, we know that x cannot be 3. If x is 3, we get a 0 in the denominator. But remember, x equals 3 is only going to happen when the square root of x equals 3. So we want to figure out when does the square root of x equal 3, and that's when x equals 9. We figure that out by squaring both sides. So that means now the other thing we have to exclude is x equals 9. So we know the x's cannot be less than 0 and the x's cannot be 9. We'll write that using our interval notation, so we'll go from 0 to 9, jump over 9, and then 9 to infinity. And that's going to be our final domain for f of g of x. Finally, we're going to talk about the composition of functions. And now this is taking two functions and it is writing them as, it's taking one function and it's writing them as two different functions. Looking at the first one, I see two things happening here. I see a cubed root and I also see an x squared plus 1. So we can write this as two separate functions. We'll start with the outside function being the cubed root of x. We also have the x plus 1 inside, and that'll be our g of x function. If I now take a look at what would happen when I put f of g of x, I would be taking that x squared plus 1, putting it into the cubed root of x, and we get back what we started with. So there's the two functions for our composition. Let's go back to those. There's our two composition functions right there. Looking at the next one, same idea. This time it's just a squared root. So why don't you pause your video and try this one. Hopefully you came up with the square root of x and x squared plus 3x minus 2. The last one now, we have an exponent of the fourth, so pause your video and try this one once again. Very similar to the previous examples, only this time we have x to the fourth rather than a square root or a cubed root, and then the x squared minus 6x plus 5. Now we could go back and we could try it again. And as you see, if I take that x squared minus 6x plus 5 and put it into the x, I get back what I started with. Alright, here's your two questions to try to put into the Google form. So the first one is finding the domain of f of g of x given these two functions here. And now your free response question, given these two functions, f of x and g of x, I want you to find g of f of x. And this is where we'll end our video for today.